Hello guys, good afternoon. Hope everything is okay. We are here with the new session of our training, which is interview preparation session. We will start with the interview preparation session in a bit. Uh, it's better that I think my screen is visible. We are ready to start the session for today. We will start with some basic questions and we will proceed with that. Uh, it's better that I think. Good. So I want you guys also have to make me interactive, and I will also make you interactive about the session, what is going on, and what will be. And I will take up the questions what you have in your mind and what you have posted in in charts, right? So we'll deeply go on and understand what from the basics, like what is data science and how these terms are related and how the maths is important in data science and all. So in this week we will grasp those all the things whatever is there in the data science. So the first question will be, what do you means what is the meaning of data science? How do you characterize the term data science? That we will understand in a bit. What what is the term data science? That's what the first question is. Let's see. So generally, uh, in the data science program, we have in our first class, whenever we will start the data science program, we have a diagram like business understanding, data cleansing means EDA part, and those all six steps are there, right? So we will be dealing with those six steps which are helpful in the data science specialized kind of things. So we will generally believe that in the data science program we have some scientific processes to predicting something, and then algorithms are there, and then tools are there, and machine learning techniques working to help to finding the patterns, right? So I will also would like to add some key points. What will be uh, what will we study generally here? We will means discuss here, right? Look into this, Khali. First is we will be using understanding understanding the data which is vastly generated. Next, we will have to like I'm not going to those 6 steps, guys. Please make to means be to understand that how the process is going to be. We will first understand the data. That is the scientific approach, right? We can also write here scientific process. Next one we have is working with algorithms. We need to suppose think of one thing that we need to predict something, and by manually we can't see all the data, and we can't figure out what we are expecting to do. So we need to go for algorithms. For that, guys, like algorithms, we generally go for programming things in the sense we generally write programs with the languages like Python, R. Then we also have Scala, and uh, Java is also there, but we generally mostly focusing on Python because Python is very particular about data science program, and it also can be understood by who means some non-technical programming kind of things like suppose uh, for data science it doesn't matter that how much efficient you are with the languages, but you need to be more specific that when which line of code is used, when to write those codes. So that is what important, so we will generally focus on that. According to that, we have designed some means we have also pre-trained models and pre-trained codes written, right? We will generally using that for the algorithms. Then we have what can I say, for algorithms I generally told that these are the algorithms we need to write in Python. So we will focus on the tools, right? Algorithms we have what supervised and unsupervised, right? We have supervised algorithm and unsupervised algorithms. We have there is a difference between supervised algorithm and unsupervised algorithms. The supervised algorithm generally does means we generally use supervised learning algorithms whenever there is a specific variable which is a dependent variable and so many independent variables will be there. We can see that we will further see that linear regression is there, where we generally focusing on a straight line equation, which is y is equal to mx plus c. Y will be the dependent feature and x will be the independent feature, where m is our slope and c is the constant, right? But in case of unsupervised learning, no such kind of things are there, like dependent feature and independent feature. We generally go for clustering and segmentation in this kind of things, right? Good. Then we have tools, guys. Tools. We will understand that what are the tools we need, means we generally need to focus on. The tools, like what I am saying, that when the tools are used, I told Python is used, R is used. Python is generally used for programming and those algorithms to be written, and R is also used for statistical analysis kind of things, like whenever we go for analytical kind of things, there we generally use means like R is basically gives more useful meaning when it comes to statistical kind of things. The next we have is Tableau, which is a visualization tool, and Power BI. Like those kind of tools are also there. So these are the tools, guys. Now we will see the machine learning techniques are also used. Machine learning techniques means when to use which statement, like classification is there, regression is there, segmentation is there, neural networks are also there. So many machine learning algorithms and machine learning techniques are there. We need to be more specific about when to use which algorithms, when to use which techniques, right? Then we have once the we generally go for in the data science whole data science specialization. We generally, from the first step, it starts with gathering the business requirements and relevant data. Then we go for, once the data is acquired, it is maintained by performing data cleansing, data warehousing, data staging, and data architecture. I can also write that, right? First gathering the data, then we will go for data cleansing. Then we will go for, after data cleansing, we will go for data warehousing. Then we will go for data staging, and then data architecture. Data architecture. So these are all the steps process means we need to involve when the data is being gathered. After that, all those steps will be used for data cleansing and make the data proper format for the modeling part of our program. Now the data pre-processing part. In the data pre-processing part, we generally go for exploratory data analysis, where data mining is there. Analyzing the data is more important, which is being especially being done by data EDA part, exploratory data analysis part, where we generally thinking of the business understanding kind of things, like first moment of business understanding, mean, median, and mode. Then we go for standard deviation, and variance is also there, and we finally go for skewness and kurtosis. We will check for the data whether the data is skewed or not, and kurtosis also we will be checking. Then the final step will be, in the final stage, we communicated the business is visually applying manner, there were skills of data visualization tools. I told Tableau, Power BI is there, and we also have libraries in Python, Pandas, and Seaborn and Matplotlib is there. Through that also we can go for data visualization kind of things, right? That's great. So we will be moving to the next question for today. That will be, what is the what is we came to know about data science. Then we will be dealing with what will be the data science, and what is data analytics, right? Okay. Oh, sorry guys, actually I haven't seen that you are also. Is that visible? Is that visible right now? Yeah. So right now it is visible. I can see that now. So we will go for now. We will go for the next question. Like, what is the difference between data analytics and data science? Right? What is the right? What is the difference between data analytics and data science? We will be like more specifically tell. I will tell about the more specific answers where we will like understand those things like point wise. Data science involves involves the task of transforming the data by using various techniques, analysis methods, and to extract the meaningful insights using which means like after data science kind of things, then it came to data analytics. Analyst can apply to their business scenarios, whether suppose think of one scenario that we get the data and the data is not in proper format, and Tableau can't recognize the data. That data is totally unstructured and the data is not accessible. Then we generally focused on those kind of things. Good. Some uh, Sahina had said that descriptive analytics plus diagnostic analysis is equal to data analyst. Good, that's good. You have grasped those mind map. That's great. That's great. So data analytics dealing with checking the existing hypothesis and information and answers questioning for a better effective business related decision makings suppose think of one scenario. We have a forecasting data. We generally go for visualizing the data. We visualize the data. Then we go for seasonality changes and all those kind of things. Right now, uh, data science involves answering the building concerns and futuristic problems, and data analysts focused generally on getting present meaning from the existing historical context, whereas data scientists go for predictive modeling. You guys might have heard about predictive modeling. That is we generally do here. Over. So data science can be considered as a broad subject that makes means use of various mathematics is there, scientists scientific tools are there, and algorithms are there for problem solving complex problems. But in the case of data analytics, we generally consider like some analytical brains and some pure of tools and statistics of visualization. Nothing else is there. So, right. So data science is vast as compared to data analytics. For data science, we need skills computer science, machine learning, software development, big data software tools Hadoop and Sparks are there, and algorithm developments are also means required. But speaking about data analytics skills, we can generally go for data analytics softwares like Tableau, Power BI, and all those kind of visualization tools. Then we can go for business intelligence tools, including Microsoft Power BI. I told like, and we also can use DBMS. Means DBM understanding of DBMS is required when it comes to the context of data analytics. There are some techniques are there, to understand with both the cases. Like for a data scientist also it is required, and uh, for a data analyst also it is required. So we generally go for that, and in that case we will focus mostly on such kind of overlapping kind of things, like basic statistical analysis must be needed, and programming including SQL, Python, R, we need to data cleanse and all those kind of things. And problem solving attitude is most important while speaking about data analytics and data science. And the most important thing where a data science scientist and data analyst should must have is storytelling, guys. That is must, because how how can you prefer, means I want to know from you, how can you prefer that storytelling is important for us as a data scientist? Anyone can answer. In the chat window I can see. Great. Okay, I see no answers here. So storytelling is important. Suppose think of one scenario that you are a data scientist or a data analyst, and your client came to visit you, or else one customer came to visit you, and you will tell something that he doesn't know, but and he don't want to know about the accuracies or the r square value or the adjusted r square value what you have in that programming kind of things. So you generally will be talking about those kind of things where your client can easily understand that, right? Great. We will be moving out to our next question, that is, okay, we will be, what is sampling? What is sampling, guys? You must means, like, as you know, in the data science kind of thing, in the data science we have math intuitions. Math is there, right? So in mathematics we are focusing on probability, linear algebra, and then what can I say, determinant matrix. That is a part of linear algebra, and then we have probability. Then we are focusing on some parts of derivative and integration also. So in the probability we have sampling techniques. How can you think of some scenarios where sampling is being important, and what is sampling is? Yeah, Salini says sampling is a technique. That's great, Salini, but how it helps us? Okay, see, data analysts cannot be data analysis cannot be done on a whole volume of data, right? We have some lakhs and thousands of people. We can't infer something from those lakhs and kind. We have to think of sampling kind of things, right? I am giving you one scenario. Suppose think of one thing that we are using a pen or a pencil, and the pencils are products on a pencil is vastly, right? One machine at a time giving 1000 of pencils. Are you going to means we do not supposed to go for checking each and every pencil whether the pencil is good or not, right? So what we do is we will check sampling techniques like hourly we will check 5 to 6 pencils and we will approve the whole lot, right? Like that we generally do. And I will be more specific about all those kind of things. So in analysis kind of things, we cannot be means like data analysis cannot be done on a whole volume of data. It especially when it involves larger data sets, it becomes like crucial kind of things to take some data samples and that can be used for representing whole the populations, right? And it is very much necessary to carefully take the sample data out of huge truly represents the entire data set. So there are mainly some categories of sampling techniques are there, which is being used in sampling. Like there are we can specifically divide the sampling technique into two types. What is one is probability sampling technique, and the next one is a non-probability sampling technique. Okay. So in probability sampling technique, we generally go for like we have clustering. Then sampling is clustered samples are there. Simple random sampling is there. Then stratified sampling is there. But in the case of a non-probability sampling technique, we have quota sampling, convenience sampling, and snowball etc. is there, and etc. is also there. So, what can l- from a sample, how do you think that it is a bit better to go for a sampling technique rather than taking whole lot of populations? First thing is it reduces the volume of data. First thing, but the second thing is suppose think of one thing that you have a huge data set of 5 6 clusters like you have a team of data science, you have a team of IT analyst, you have a team of managers, you have a team of HRs. There are 4 teams and you are being sample that populations and you came to know that there are 4 categories by categories by sampling only. But how did you sample, how your sampling was accurate after so many attempts? You what you have done like you have chosen your sample got one people from each of the departments, right? Like one from the data science team, one from the HR team, one from the analyst team, and one from the manager team. Then that means your job is almost done rather than getting into every each and every people and a whole lot of data science people, rather than checking all, you go just by four people's, means by four of the employees, you just got the data that these are four clustered samples are there, right? That's great. Yeah, just like four moments. Great. So, okay. Now we will be moving some haphazard questions, right? We will not go to some particular questions. So we will generally mostly focusing on the data science questions, what are being asked in the interviews, right? So the next question will be like, how can you differentiate between like overfitting and underfitting? How can you, right? How can you differentiate what is overfitting and what is underfitting? I am looking at the chart window. Simply bias and variance. Okay, what is the bias and variance? We will look into that after some time, but what is this, guys? Underfitting and overfitting. Yes, I got some answers like Saina says underfitting is data is not worked well in training itself. Overfitting is data is work well in the training but not work on test data. The data have more accuracy than training data is overfitting. Trained data have accuracy more than the data is underfitting. Good, good. That's great that I'm getting some responses. I hope you guys should continue with the responses. We will understand. We will understand what is that and all about, right? Simply listen to me carefully. Listen to me carefully. You will get all the ideas, right? It like overfitting and underfitting. These two terms came to mind when the model's performance is going to be measured. When the performance of the model is going to be measured in the training set or in the test set, right? So the model performance well only for the sample of training data, right? If the model performs well only for the sample of training data, if any new data is given as input to the model, it fails to provide the result. Then this condition is called low bias and high variance. Variance is high because it is deviating. It is deviating maximum amount. Like we are giving a data input and it is not even recognizing the data which is previously present there. So that is high variance. And this type of problem is called hmm, overfitting. Got it? So while coming into the next, that is underfitting, we have if the model is so simple and that is not able to identify the correct relationship between in the data, and hence it doesn't perform well even in the test data, then it might happen that due to high bias and low variance, means low variance, so the data is going to be underfitting. Like I generally have one such example for underfitting. Suppose think of one scenario that you did well in all the pre-exams, like pre-tests, and whenever it came to the main test, you failed. What is that reason? Why do you think that it is necessary? Right? That case is called underfitting. Got it? Good. So we'll be moving to the next question. So that is a data science question is over. So the next question will be we will take is, okay, I said we are using linear algebra. Linear algebra, there is a concept of matrices and determinant. From that, we have one question is there. What is eigenvectors and what is eigenvalues? What is? Okay, good. Done. I want answers, guys. What are eigenvalues and what are eigenvectors? They are just used for 2D transformation. Okay, okay, this is some responses I am getting. That's great, guys. That's great. Okay, for the purpose of transformation, we generally use eigenvalues and eigenvectors, right? Okay, I'm explaining. Just it will take 2-3 minutes. Just listen to me carefully. So in the case of eigenvectors are column vectors, or those are also called as unit vectors, right? Whose length or magnitude is equal to what? 1. They are also called as right vectors. Hmm. And eigenvalues are coefficients. Eigenvalues are coefficients that are applied on eigenvectors. Eigenvalues are Eigenvectors are on top of eigenvalues, right? So the a matrix, if we go for a matrix and that can be decomposed into eigenvectors and eigenvalues, this process is called eigen decomposition. From the process of eigen decomposition, we generally get eigenvectors and eigenvalues. Fine, means first case we will get eigenvalues, then we go for eigenvectors, right? There are eventually used in means like these eigenvalues and eigenvectors. These are generally used in the case of machine learning methods like we have what can yeah we have PCA is there, right? Principal component analysis. There in that case we generally like use eigenvalues and eigenvectors for gathering values, means valuable insights from like matrices. Means matrices are there, right? Right. We will be discussing about some more important things like in generally it's kind of data science interview questions. These are the most important things are being asked, like statistical independence of the questions. Those statistical independence of the questions are most important. So we'll be discussing about that also. So how do you define that p value, whether it is high is good and low is good, right? What uh, does it mean when the p values are high and low? Okay. How can you define whether the p values? What about the p values? Yeah, Salini says when p value is less than 0.05, we say p value is significant. That's great, Salini. That's great. What are these things when it comes to like value kind of things like r square is there, adjusted r square is there, all those kind of things, p value is there, t statistics is also there. What are these stands for? These statistical kind of things, why we need it all needs to check whether means like whether our the performance of our model, right? Good. So a p-value is a measure of probability of having results equal to or more than the results achieved under a specific hypothesis, assuming that null hypothesis is also correct. Because whenever we are assuming something that is the null hypothesis, and we are thinking that it is correct only, by taking those into consideration we move forward. So this represents the probability that the observed difference occurred randomly by chance. Means like what can I say? The probability whenever we are checking these kind of things and hypothesis, null hypothesis is correct, it shows that the observed difference which is going on, which is occurring, that is randomly happening, right? So as Salini says, this p value when it which is less than 0.05 or equal to 0.05 means that the null hypothesis can be rejected and the data is unlikely with the true null. Right? Got my point. I think whenever that p value we got less than 0.05 and then we can go for rejecting the null hypothesis. That is the significance of p value. If the p value is greater than 0.05, it indicates what? It indicates that the model is in the favor of null hypothesis. We can't reject the null hypothesis, right? It means that the data is like true null data, right? So if the data is equal to 0.05 means, hmm, what is that? We can go either with the null hypothesis or with the, hmm, good. Yeah, Salini says something great, that is p high null fly. Whenever the p value is high, we can reject the null hypothesis. Whenever p value is low, we can go with the null values, right? Assignment, someone says assignment. H not or H1, good, good. When p value is greater than 0.05, then we say values are not statistically significant. Great, that's great, Salini. Okay, so we will be dealing with one more question today. What is resampling do, guys? What is resampling? Okay, so resampling we are talking about. So resampling, whenever I am speaking of resampling, I I hope some answers in the chat window will appear. That's why I kept myself silent for few seconds, and I also got some answers. Akhil says it is a technique. That's great. Like simply k folder, cross validation is also there. And Salini also said repeatedly drawing samples from a data set, and by the every data point involved the testing as well as training. That's great. That's great. So what exactly resampling done? What is resampling required? Why is resampling required, and what it is doing in the data set, and why do we require that? I cannot means we are going to understand, right? So resampling is a methodology we generally use to sample the data for improving the accuracy, right? For one time, if we sample, it might not happen that we will get the things which we are actually in need of. But whenever it comes to resampling, we generally do the resampling technique for, hmm, getting more accuracy. So it is done to ensure that model is good enough to be trained by the model of different patterns, and also dataset ensures variations of dataset can be handled by the technique, right? It is also like done in the cases where models need to be validated using random subsets, or when substituting levels on the data points, while performance testing of the dataset, like performance, we have done some sampling technique and resampling testing techniques, and then we are going for performance checking. In those cases also, resampling is much helpful. Okay, so we'll move to the next question what we have today. Okay, sampling kind of things. Why did this sampling and sampling, oversampling, these terms came to our mind? Why we are going for these kind of things? Oh, right, because we are playing with the data, and the data is more accurate to be with, and data we have to be in crisp manner, less in context, all those kind of things, right? Okay, we'll move to the next question what we have today. What do you understand by imbalanced data? Guys, I'm asking. Yeah, that's great. I want some answers. Yeah, train test split, only bias type of data points are present. Great, great. So I got some answers, and that is also helpful, right? So whenever data, we can say imbalanced is the data is said to be imbalanced if the distribution is unequal. Unequal means not exactly 50-50, but for the model performance, what we required is we can train our data like 30%, and we can check with the data for more than 60% or 70%, right? So these guys, these data sets means results in an error in the model performance and in accuracies also, right? If the data set is highly imbalanced and distributed is not, distribution of the data is not good, and some classes are there with some low numbers, like very very less numbers, like 1 out of 100 is there, then those are also called as imbalanced data set. Because of this imbalanced data sets, we generally get less accuracy, right, in the result case. Good. Saina says something. That's great. Okay. So the next question we have is like, okay, what is the Yes. That is what the next question is. What is the difference between an expected value and an mean value? What is that all about? We have heard about expected value, right? It is in probability. Mean is also in statistics. Okay. Phil says mean is average value. I didn't see any answers. Okay, no issues. So, what we can understand from the mean value and expected value is there are not many difference between these two, but it is also noted that they are used in different contexts. Like someone is means both these kind of things are used for different contexts, right? The mean and value generically refers to the probability distribution, where whereas the expected value is referred to in the context involving what can the expected value can involve. That is random variables, right? Good. Huh. I will be happy that this session will be a great session. We will be dealing with the session in the upcoming week from means this whole week. So that's great, and that's it for today. We will meet again tomorrow. Thank you all.